Hey there. We are going to work on Home Connection, page 17 and 18, titled Expressions, Equations, and Stories. Make sure my name is up at the top. Number 1, write an expression with parentheses for each statement below. I multiplied 7 times 8, and then I added 9. So first, the student multiplied 7 times 8, hug it with parentheses, and then I added 9. Letter B says, I multiplied 3 times 12, put in parentheses because that's first, and then I multiplied the product. Product is the answer when you multiply, of 3 times 12 by 5. So I multiplied the product by 5. I subtracted 14 from 30. So that means I had 30 first. Then I subtracted 14, hug it with parentheses. And then I multiplied the difference. Difference is the answer when you subtract, by 6. That's the equation for that one. Number 2, Emir loves multiplying by 99 because he can use the over strategy. Write an expression to show how Emir would solve 99 times 76. So we have to write our number sentence using that over strategy that he would love. So which number would we go over with? Yeah, instead of 99 times 76, it would be 100 times 76. But since we go over by one group of 76, then we have to subtract a group of 76. What is 99 times 76? So now we have to solve. So let's take the parentheses part first. 100 times 76. First I take 1 times 76. Then I attach 2 zeros because it's 100 times larger than that. Or say 1,000 times larger than that. Then I subtract 76. In my head, here's what I think about. I think about having 600 and jumping back 70. If I jump back 70, I'm at 7,530. Now I need to jump back 6. 30 minus 6 is 24. So 7,524 is my answer. I'm going to rewrite it here. Then it says solve a different way, or show a different way to solve 99 times 76. We're going to do traditional. You may not be familiar with traditional, but hang with me. We'll be practicing it later on in this school year. So just hang with me for this. When we start with traditional, we start with 6 right down here. We take 6 times 9, which is 54. So I write my 5 up here, my 4 down here. Then I take this 6 and multiply it times this 9, and I get 54 again, but I have to add 5 more. 54 plus 5 is 59. I'm done multiplying this by the 6, and I'm done with this 5. Since I'm done multiplying with this 6, I'm going to put a 0 right there to show that I'm done with it, and it's going to be a placeholder. Next, I'm going to take this 7, and I'm going to multiply it by this 9. 7 times 9 is 63, so I put the 6 up here and the 3 down here. Then I take 7 times this 9, and I get 63, but I have to add 6 more. 63 plus 6 is 69. So I put my 6 here, my 9 here to line them all up. I'm done with the multiplying portion. Now I come down here and I'm just going to add. 4 plus 0. 9 plus 3 is 12. I put my 1 up here, my 2 down here. 1 plus 9 is 10. Plus 5 more is 15. Put my 1 up here, my 5 down here. And then 1 plus 6 is 7. And I should get the same answer because we solved it, the same problem, just a different way. So it says show a different way. I'm just going to draw an arrow to show my way that I used. Let's go on to number 3. Erica likes to multiply by 25 because she can use the double half strategy. Write an expression to show how Erica would solve 25 times 28. So we have to double in half. Which number are we going to double and which number are we going to cut in half? Yeah, we're going to double the 25. So I'm going to show that like this, doubling it. And then I'm going to multiply half the 28. Half of 28 is 14. So I'm going to show that we doubled the 25, half the 28. And I'm going to rewrite my problem. 25 doubled is 50. And 28 cut in half is 14. We could even double in half again. Let's show what Erica would do next. Double 50 again. 100. Half 14. 7. What an easy equation to solve now, just by using that doubling and halving strategy. So it says, what is 25 times 28? Well, what is this when we multiply it out? 100 times 7 is 700. Then it says, show a different way to solve 25 times 28. I'm going to show you a way that's going to make it pretty easy. We're actually going to show 28 as the same as 4 times 7. So now I'm going to take these numbers, 4 times 7 times, I still have my 25 left. So my 25 times 4 times 7 will get me 28. And then what I'm going to do is I'm going to take 25 times 4 first, because I like thinking about quarters. And if I have 4 25s or 4 quarters, I have 100 thens, and I still have times 7. Number 4, evaluate each expression. Remember, evaluate means solve. Okay. Well, since I have multiplication right down here, I can solve these in any order. I'm actually going to take 10 times 10 first because that is 100. And then I still have my 25 left. 25 times 100. I'm going to take 25 times 1 first. And I'm going to attach 2 zeros. Because it's 1,000 times larger. 2,500. Let's go to the next one. Now this one looks a little bit different. We're not used to seeing a number hugged right up next to the parentheses. See how it's tight in there? There's no symbol between. If there's no symbol between this number and these parentheses, we can assume it means multiplication. We can assume there's the multiplication symbol in there. So go ahead and add that. And I am going to note that I have an addition sign here. So what I'm going to do first is I'm going to do the parentheses. 4 times 4 here is 16. 3 times 3 is 9. Now I need to take this 4, and remember I'm assuming there's a multiplication symbol. I need to take 4 times 16 first. And I need to add, there's my addition sign. And next I need to take 3 times 9 next. For 4 times 16, here's what I think about. I think about 2 times 16 and then doubling it. What is 2 times 16? Yep, I get 32. And now I need to double 32. 32 doubled is 64. So I'm going to write 64 right here. And then 3 times 9 is 27. Now I need to add these two together. 64 plus 27. 4 plus 7 is 11. 6 plus 2 is 8. Plus 1 more is 9. So I get 91. I'm going to circle my answers so I can find them. All right, and the last one, it looks like they used the over strategy. 100 times 89. 1 times 89 is 89. Attach 2 zeros. Minus a group of 89. Now in my head, here's what I'm going to think of to subtract these out. I'm going to take 900 and I'm going to minus 80. I keep my 8,000. 900 minus 80 is 8,820. And now I need to subtract 9 more. I think 20 minus 9 is 11, and I keep my 8,800. I can circle that. All right, remember, if at any time I go too fast, pause it to catch up. Let's flip to the back. For each problem below, use numbers, words, or labeled sketches to solve the problem, and I have to show my work. Then I have to figure out the best way to handle the remainder, if there is one. They also want me to write an equation to show the problem, the answer, and I have to label it. It's a lot of steps, so I have to make sure I get them all done. Okay, problem A. 38 fifth graders at Vernon Elementary are going on a field trip to the art museum. They are riding in vans that each hold 9 students. How many vans will they need for everyone to get to the art museum? So what's my equation? Let's start with that. I have 38 students divided by 9 that can go in a van. Okay? So in my head, I'm thinking 9 times what gets me super close to 38 without going over? 9 times what? I know 9 times 4 is 36, which means I have 2 left over, right? Remainder of 2. So that means that I could take 4 vans, but I'd have 2 students that are still waiting. So 4 remainder 2. What do I need to do then? If I have 2 students still remaining, what do I need to do? I have to get another van. So instead of 4 vans, I need 5 vans. Okay, so did we solve the problem and show our work? Yes. Did we handle the remainder? Yes. What did we do with the remainder? We rounded up, which means we got another van. Let's write that. And we wrote an equation. Let's go to letter B. When Alex and Marcus went to the store with their mom, she said they could split the change evenly. The total cost of their groceries was $57.32. She gave the cashier 3 $20 bills. How much money did Alex and Marcus each get? So first, let's figure out how much money their mom gave them. She gave them 3 $20 bills. How much money is that? Yeah, that's $60. Their groceries came to be $57.32, so they had to pay that amount. So we have to take $60 minus $57.32. All right, to solve this problem, I'm actually going to draw a number line. I'm going to draw it right down here, the bottom. Well, I'll do it up here, so if anyone wants to do the challenge, they can. I'm going to put 5732 on the number line, and I'm trying to see how many jumps it takes to get to $60. First, I'm going to jump 8 cents. When I jump 8 cents, that gets me to $57.40. Then I'm going to jump 20 cents. Not 20, I mean 60 cents. Jumping 60 cents gets me to $58. My last jump is $2. This is the exact method you think of as you get older when you count back change to people. If something costs $57.32 and somebody gives you $60, this is how you count back change in your head or count back change to them, which you'll learn as you get older. Now to figure out what my answer is, I have to look right up here. $2 plus 60 cents plus 8 cents. And I get $2.68. So $2.68. Now that was the change they had left over. They have to take that and they have to divide it by 2. Okay, dividing it by 2. So first of all, I think of what's half of $2? $1. What's half of 60 cents? 30 cents. What's half of 8 cents? 4 cents. Put it all together. $1.34. Okay? So what we did with the equation is we split up the money. We divide it in half. You can go on to do the challenge if you'd like. Please make sure if you have any questions to just ask Mrs. Wolthy when you turn it in. Thanks, guys.